Sometimes the best way to wrap your head around something super complex is just to start with a simple story. But what happens when we pull back the curtain on that story? What happens when we look at the mind-bogglingly intricate machinery that's actually at work? So, that's what we're going to do today. We're taking a journey inside the human body, and we're going to contrast a simple little tale with the absolutely astonishing reality that is happening inside you right this second. Let's dive in.
Meet our guide for the story part of our journey, Gilbert. Yep, he's a grape, and he's about to go on a pretty epic adventure. He's going to give us the play-by-play from his, let's say, unique perspective. It's a fun way to get started, but trust me, it's only the very beginning of our exploration.
So Gilbert's big trip kicks off the second he gets popped into a mouth. It's warm, it's wet, and digestion starts immediately. You've got the mechanical chomping, breaking things into smaller bits, and at the same time, saliva starts the chemical breakdown. For Gilbert, this is just the first stop on a much, much longer tour.
All right, so with that first stage done, Gilbert makes it past the teeth. He gets swallowed, and now he's heading down the chute toward the esophagus. His grand tour has officially kicked off. As he's traveling down this food chute, Gilbert feels this really powerful squeeze. The walls of the esophagus are contracting behind him and then relaxing in front of him, just pushing him right along. He calls it getting squished, which honestly is a great word for it. It's simple, it's effective. But this is where we're going to hit pause on our simple story, because to really get what's happening, we need to look at the incredible science behind that squish.
So let's zoom in on that squeeze. What is actually happening to create that motion? Because this isn't just a simple, tube squeezing shut. No way. This is a beautifully coordinated biological engine at work. And that's the real question, right? How does your body take a signal from your brain and turn it into actual physical force? The answer is buried deep, deep inside the microanatomy of your muscle tissue, and it is way more dynamic than any simple story could ever tell.
To find the engine, we have to zoom in. I mean, way in. A whole muscle, it's kind of like a thick rope made of smaller ropes, and those are called fascicles. Then each of those is made of even smaller threads, the muscle fibers. But the real engine is hidden even deeper inside those tiny threads.
Okay, let's go deeper. As you can see here, inside every single fiber are thousands of these tiny strands called myofibrils. And if you look closely, you can see they have this striped pattern. Each one of those repeating stripes is a sarcomere. This is it. This tiny little structure is the microscopic engine that powers every single movement you make. Now, the science behind this is called the sliding filament theory. Sounds pretty fancy, right? But the core idea is actually pretty straightforward. Inside each of those sarcomeres, you've got two types of protein strands, thick ones called myosin and thin ones called actin. Now, to make a muscle move, these strands don't shrink or get shorter. They just slide past each other, kind of like lacing your fingers together.
And it all happens in a flash, really, in just a few key steps. First, your brain sends an electrical signal, zap. That signal unlocks a flood of calcium ions. The calcium then lets the thick and thin filaments grab onto each other, forming what's called a cross bridge. Then they pull, causing the filaments to slide. And when millions of these tiny engines do this all at once, the entire muscle shortens. Boom, you've got force.
I absolutely love this analogy. Think of the thick myosin filaments as a boat full of rowers, and the thin actin filaments, that's the water. The little myosin heads are the oars. They grab onto the actin, pull, release, and then they reach out to grab and pull again, over and over. Billions of these molecular oars all rowing in perfect unison. That creates the incredible force of a muscle contraction. And that is the reality behind Gilbert's simple squish.
But hold on, all those tiny engines, all those little rowers, they need fuel to keep going, right? And that's where Gilbert comes back into the picture. His whole purpose on this journey is to become that fuel. So how does the body deliver those nutrients from his digestive system to every single one of those muscles? Well, it takes a delivery service on an almost unbelievable scale. Just let that number sink in for a second. 60,000 miles. If you were to lay out all the arteries, veins, and capillaries in your body end to end, they would stretch more than twice around the entire Earth. This isn't just a network, it's a colossal highway system that delivers fuel and oxygen to every last cell.
And this whole delivery service, it's a team sport. Your lungs bring in the oxygen. Deep inside these tiny air sacs, that oxygen passes right into the bloodstream, where it hitches a ride on red blood cells. And then the heart pumps those oxygen-packed cells through that 60,000-mile network, delivering fuel to every single one of those molecular engines we just talked about.
And the pump for that whole network? Your heart. On average, it beats 100,000 times a day, every single day. It is a relentless, powerful muscle just making sure that delivery service never, ever stops running.
Okay, let's check back in with Gilbert's journey. He's made it through the stomach, the small intestine, and now he has arrived in the large intestine. And it's here that he discovers he is not alone. Not even close.
Gilbert calls them his peeps, and there are trillions of them. These guys aren't invaders, they are essential residents. These good bacteria are absolutely critical for breaking down what's left of the food, for creating vitamins, and for just making sure the body can absorb all the useful stuff.
This vast, invisible world has a name. It's called the human microbiome. It is an entire ecosystem living in you and on you, made up of thousands of different species. The sheer number of these microbes is just staggering, and honestly, we're just beginning to understand how deeply they impact our health.
And that's what's so fascinating. This is an old, settled science. This is the frontier. As this quote gets at, we're still figuring out the whole chicken and egg relationship here. Does a change in your microbiome cause an illness? Or does an illness cause your microbiome to change? It just goes to show how deeply connected these tiny helpers are to our overall health.
Okay, so let's bring it all home. We started with a really simple story, right? A Grapes Grand Tour. But at every single step, when we decided to zoom in, we found a reality that is just almost unbelievably complex and frankly elegant.
I mean, just look at the difference. The simple story says a grape gets squished. The reality? Trillions of molecular motors are firing in perfect unison. The story says food becomes energy. The reality is a 60,000-mile highway powered by a heart that beats 100,000 times a day. The story says Gilbert meets some peeps. The reality is a symbiotic relationship with an invisible ecosystem of trillions of microbes that are essential for us to even survive.
Simple stories are useful, for sure, but they barely scratch the surface of the universe that's operating inside you. Your body is a network of these intricate systems performing countless miracles every single second. And it kind of leaves us with one final thought. What other incredible invisible engines are at work inside you right now without you ever even noticing?